Okay, so for this example, we want to find the limit as x approaches 0 of x squared times the sine of pi over x. And you'll notice right away that if you try evaluating this directly, you're going to be dividing by 0. You'll also notice that it's not an indeterminate form because substituting 0 in gives you 0 times something undefined, and that is not the form 0 over 0 or infinity over infinity. So we've got no choice but to find some other way to get our hands on this limit. And the best way to do it is to use the squeeze theorem. And the squeeze theorem is all about trying to make an argument that is bounding your function above and below and squeezing the limit to a single point. Now, we all know that the sine function from basic trigonometry is always between -1 and +1. And because of that, we can now write an inequality using the sine function part of this function. So to do that, we're going to start off with the fact that the sine of anything, including pi divided by x, is always less than or equal to 1 and greater than and equal to -1. And so that's our basic bound on our trig function. The next thing we want to do is multiply through by x squared. And now remember, x squared is always positive or 0, so therefore multiplying an inequality, there's no need to worry about changing the directions. So we multiply all three parts of this by x squared. So we're going to have negative x squared less than or equal to x squared times the sine of pi over x less than or equal to positive x squared. And now we're going to take the limit of all three sides of this inequality as we approach 0. So we're going to have the limit as x approaches 0 of negative x squared, which is less than or equal to the limit as x approaches 0 of x squared times the sine of pi divided by x, less than or equal to the limit as x approaches 0 of positive x squared. The next thing we can do is now directly evaluate the furthest left and the far right limit by direct substitution. So if we do that, that first limit is just 0. And again, we have our limit in between. Limit as x goes to 0 of x squared times the sine of pi over x. And then the limit on the right, well, that's going to be 0 as well. So if you are less than or equal to 0 and at the same time greater than or equal to 0, you gotta be 0. There's no room in between there. So therefore, we conclude that the limit as x approaches 0 of x squared times the sine of pi divided by x is equal to 0 by the squeeze theorem.